In this video, we're going to look at our first investment scenario. So this is where someone is putting money into something else and that value is going to increase, and then what they're going to do is use that money afterwards. So the first one we look at is perpetuities. We then go on and look at other kinds of investments as well. So a perpetuity comes from the word perpetual, which means to carry on forever. Okay, to infinity. So this will continue going no matter what, and the balance will remain the same. And this is critical. The balance remains the same. So take this example. A maths teacher decides that they want to have a retirement fund that lasts forever. So that's what a perpetuity account does. It actually will go on forever. The money that you put in there doesn't change. He opens up a perpetuity account which gives 4.5% per annum compounding monthly on his investment. What monthly payment will they be able to withdraw if they have a retirement fund of $850,000? So the idea with a perpetuity account is you put the money in the account. So here's the perpetuity account. Okay, so we put our $850,000 in there. Okay, and we know that that goes up by an interest every month. Okay, plus, going up in value. Then the person, the investor, let's call them now, will take that money away from the account every time it is added. So whatever the interest is, it gets added first of all. So we add the interest plus the interest, and then they take the interest over to their account, and they can live off that money. So if you've got enough invested, you can actually constantly get the interest from your perpetuity account, and then you can actually live off that money. So we need to work out how much interest is that $850,000 going to generate, and therefore what's this investor's money going to look like every month. So in order to do that, we need to use Finance Solver. So if we look at N would just have to be a single payment this time. It's a bit like interest-only loans in that respect. I is 4.5%. PV this time is an investment, so therefore it has to be negative. And this is the key bit that's different. PV is negative because we have put the money in something else. PMT we're going to leave blank because the question was how much can they withdraw. So that's the amount we're looking to see if they pay us. And future value you want to be the same. But notice how future value, as opposed to loans, future value now is positive. So therefore, the balance will not change month to month, which is why N can just be 1 or N could actually be 5. It doesn't matter what N is in this. The balance won't change. So the PMT will come out as the same value. This is a 12-12 scenario because it's monthly. And if we now use that calculation, that will give us the payment. Now, I'm going to show you a slightly different way of working it out as well. The sort of manual way is if you think about the fact that 4.5% is per annum. So what's that per month? You divide it by 12. Okay, so we get 4.5 over 12 gives us 0.375% per month. I then want to turn that into a decimal, so I'm going to divide it by 100. And I'm going to times that by the 850,000. And that will give me 0.375% of 850,000, which turns out to be quite a bit actually, 3,187.5. So I'm just going to copy paste those workings in as well, because that's one way of working this question out. I'll leave them over there. Move my face as well. Okay, so that's there. That's one way of working it out, and the other way is using Finance Solver. So we'll press Menu, Finance, Finance Solver. Here we just hit 1, 4.5, negative 850,000. Leave that blank. Positive 850,000. 12, and then we skip down to PMT and we'll press enter. And look, same value. So that is the other way of working it out. Both ways are fine, because they get the same answer. I don't really need that there, do I? Just put that there. 3187.5. So your final answer should say 3187.50 per month. So that person, by investing so much money in a perpetuity account, will be able to withdraw that amount of money every single month, and they will still have the same money in the account at the end of it. So that's what a perpetuity account is for. A common use of a perpetuity account actually is things like scholarships. So we're going to look at that question next. So a university wishes to offer a scholarship for aspiring athletes. They put 50 grand in to invest, and they want to be able to withdraw 3,200 per year for a student. So what rate would they need if they invest in a perpetuity account which is adjusted annually? What rate of interest will they need to be able to pay this amount? So let's just go through and see what we've got. We've got our principal value. We've got our PMT. The rate, we don't know. The PPY, CPY is actually 1 in this case because it's an annual adjustment. Future value is also the same as PV, but just PV will be the negative version. Sorry, FV will be, PV will be negative. And so, have we got everything there? Oh, and N is just 1. N can just be 1 for these questions. So, 1, unknown, minus 50,000. It's minus because we've invested it. PMT is positive 3,200 because we want to get paid that money. FV is positive because we want to have that much money left owing to us in the account. And then PPY, CPY is 1 and 1. All right, and if you hit enter on that, we'll see what rate is required. So let's just go through. So 1 there, unknown, 50,000, 3,200, positive 50,000 because it's still owing to us. 1, 1, okay, hit enter. So we need a 6.4% rate. 6.4%, which is pretty doable if you find, some sort of share market